Hey everyone, welcome back to the channel. Today, we're diving deep into the cosmos to explore a celestial story unfolding right in our cosmic backyard. Mars, our red neighbor, has a captivating secret. Its moon, Phobos, is on a collision course with the planet it orbits. Now don't hit the panic button just yet. This cosmic drama won't reach its climax for another 30 to 50 million years. But that doesn't mean we can't ponder the possibilities, right? I mean, imagine a future where humanity could actually intervene in such a cosmic event. The big question is, can we save Phobos? And if so, how? Let's break it down. So, what's pushing Phobos towards its demise? What cosmic forces are at play here? It all boils down to gravity, my friends, the universal force that shapes the cosmos. Gravity is the invisible hand that orchestrates the dance of celestial bodies. You see, Phobos isn't exactly a well-behaved moon. Its orbit is irregular and somewhat erratic, making it a fascinating subject of study. It orbits Mars at a daringly close distance, a mere 6,000 kilometers above the Martian surface. This proximity is both intriguing and perilous. To put that into perspective, that's closer than some satellites orbiting Earth. Imagine a moon orbiting closer than our own geostationary satellites. Now this proximity comes at a price. The gravitational forces at play are immense. Mars, with its gravitational muscle, exerts powerful tidal forces on Phobos. These forces are relentless and unyielding. These forces are like invisible hands constantly squeezing and stretching the moon. It's a cosmic tug-of-war that Phobos cannot escape. Over eons, these tidal stresses take their toll. The moon's structure weakens, and its fate becomes inevitable. Think of it like this. Imagine stretching a rubber band repeatedly. Each stretch weakens it a little more. Eventually it either snaps or loses its elasticity. Phobos is facing a similar fate. Similarly, Phobos is caught in a gravitational tug-of-war with Mars. It's a battle it cannot win. With each orbit it loses a tiny bit of altitude, inching closer to its inevitable fate. The descent is slow, but certain. Now, there are two possible scenarios for Phobos's grand finale. Each one is as dramatic as the other. In one scenario, the tidal forces become so intense that they rip Phobos apart, shredding it into countless fragments. This disintegration would be a spectacular event. These fragments, caught in Mars's gravitational grip, would then spread out, forming a spectacular, albeit temporary, ring system around the red planet. A cosmic necklace, if you will. Imagine the view from Mars then. A ringed planet, a sight to behold. The other possibility is a bit more dramatic, a cosmic event of epic proportions. Phobos, unable to withstand the relentless tidal forces, eventually succumbs to Mars's gravitational pull and crashes into the planet, a cataclysmic end. This cosmic collision would release a tremendous amount of energy, creating a massive impact crater on the Martian surface. The aftermath would be monumental. Either way, the clock is ticking for Phobos. Its fate is sealed, but the timeline is still uncertain. But here's the exciting part. We might just have a say in how this cosmic drama unfolds. Human intervention could alter the course of this celestial story. Alright, so we've established that Phobos is in a bit of a cosmic pickle. This small, potato-shaped moon is slowly spiraling towards Mars, and if we don't intervene, it could eventually crash into the planet, creating a catastrophic event. But what can we, the intrepid explorers of the cosmos, do about it? How can we prevent this impending disaster and perhaps even turn it into an opportunity for scientific advancement? Well, it turns out we've got a few tricks up our sleeves. Ideas that sound like they're straight out of science fiction but are rooted in real science. These innovative solutions could not only save Phobos but also pave the way for future space exploration. One strategy involves fighting fire with fire, or in this case, gravity with gravity. By understanding and manipulating gravitational forces, we can alter Phobos's trajectory. By attaching powerful thrusters to Phobos, we could potentially counteract Mars's pull. These thrusters would need to be strategically placed and precisely controlled to achieve the desired effect. These wouldn't be your average rocket engines, though. They would need to be advanced, capable of sustained operation in the harsh environment of space. We're talking about ion thrusters, highly efficient engines that use electricity to accelerate ions, creating thrust. These engines are already being used in some of our most advanced spacecraft. Powered by solar panels, these ion engines would provide a gentle but continuous push, slowly nudging Phobos away from Mars over time. This method would require patience, but it could be a viable long-term solution. Another idea involves a bit of cosmic billiards. By carefully calculating trajectories, we could use other celestial bodies to influence Phobos's path. We could use Mars's thin atmosphere to our advantage. This would involve some complex maneuvers but could be highly effective. By deploying large, drag-inducing structures in Phobos's path, we could use atmospheric drag to gradually slow down the moon, causing it to spiral outward into a higher, safer orbit. This method would require precise engineering and timing. Now remember those stress fractures I mentioned earlier? These cracks are a sign of Phobos's structural weaknesses, but they also present a unique opportunity. Those present another challenge but also an opportunity. By understanding the moon's internal structure, we can develop strategies to reinforce it. See, Phobos isn't exactly a solid hunk of rock, it's more like a loosely held together pile of rubble, which makes it both fascinating and fragile. It's riddled with cracks and fissures, making it structurally vulnerable. But this vulnerability could be turned into a strength with the right approach. But what if we could turn this weakness into a strength? By carefully managing the internal stresses, we could stabilize Phobos. By carefully mining resources from Phobos, we could potentially alleviate some of the internal stresses that are tearing it apart. This would require advanced robotic miners capable of operating in space. Imagine robotic miners, tirelessly extracting valuable materials while simultaneously strengthening the moon's structure. This dual-purpose approach could be a game-changer. It's like giving Phobos a cosmic makeover from the inside out. This transformation could make Phobos a more stable and useful body in our solar system. And here's a truly ambitious idea. What if we turned Phobos into a celestial lifeboat, a stepping stone for humanity's expansion into the solar system? This could be a monumental leap for space exploration. Imagine a permanent base on Phobos, a hub for scientific research, resource extraction, and even space tourism. This base could serve as a launchpad for missions deeper into the cosmos. Its low gravity would make it an ideal launchpad for missions deeper into the cosmos. This vision of Phobos as a bustling hub of activity is not just a dream, but a potential reality with the right technology and determination. Now I know what you're thinking, Neil, you're talking about moving a moon. Isn't that a tad ambitious, even for a species that dreams of colonizing Mars? And you'd be right to question the sheer scale of such an undertaking. But here's the thing. Saving Phobos might be more attainable than you think. Consider this. Compared to, say, deflecting a planet-killing asteroid or terraforming Mars into a second Earth, stabilizing Phobos is a relatively localized challenge. We're not talking about altering the course of celestial bodies across millions of kilometers. We're talking about making incremental adjustments to the orbit of a moon that's already in close proximity to a planet we're actively exploring. Think about it. We've already landed rovers on Mars, machines that are beaming back incredible data and paving the way for future human missions. We're developing powerful rockets capable of carrying humans to the Red Planet. So, in the grand scheme of things, developing the technology to nudge Phobos into a more stable orbit might not be as far-fetched as it seems. Moreover, we could leverage the resources available on Mars itself. Imagine setting up a mining operation on the Martian surface, extracting resources that could be used to build and fuel the spacecraft and equipment needed for the Phobos rescue mission. This would eliminate the need to transport massive amounts of material from Earth, significantly reducing the cost and complexity of the project. So, we've explored the how of saving Phobos, but the bigger question is why. Why should we invest our time, resources, and intellect into saving a moon that seems destined for destruction? Why should we, as a species, even bother to save a doomed moon? What could possibly make this endeavor worthwhile? Well, beyond the sheer audacity of it all, there are some compelling reasons why preserving Phobos might be in our best interest. It's not just about the challenge, it's about the opportunities it presents. First and foremost, Phobos could serve as an invaluable stepping stone for our future explorations of Mars and beyond. It could be the gateway to the Red Planet. Imagine a permanent research base on Phobos, a hub for scientists and engineers from around the world. This base could be a melting pot of ideas and innovations. From this base, we could study Mars in unprecedented detail, unraveling its geological history, searching for signs of past or present life, and even testing technologies for future human missions to the surface. The potential for discovery is immense. And remember that low gravity I mentioned earlier? It's a game changer. That's not just convenient for building structures, it's also incredibly useful for launching spacecraft. the energy savings could be monumental. See, it takes a tremendous amount of energy to escape a planet's gravitational pull. This is one of the biggest challenges in space travel. But with Phobos' weak gravity, launching missions to other parts of the solar system would be significantly easier and cheaper. This could revolutionize our approach to space exploration. We could use Phobos as a cosmic launchpad, sending probes and spacecraft to explore the outer solar system and beyond. The possibilities are endless, but perhaps the most intriguing reason to study Phobos is the secrets it might hold about our own planet's past. This small moon could be a key to understanding our own origins. You see, there's a theory that Phobos and its smaller sibling, Deimos, were not always moons of Mars. They might have had a very different past. Some scientists believe they were once asteroids wandering through the solar system until they were captured by Mars's gravity. This theory opens up fascinating possibilities. If this theory holds true, then studying Phobos up close could provide us with valuable insights into the early solar system, the formation of planets, and even the origins of life itself. The implications are profound. Who knows what secrets this little moon might hold, waiting to be unlocked by our insatiable curiosity. The journey to uncover these mysteries could redefine our understanding of the cosmos. So there you have it. Saving Phobos might seem like a daunting task, but the potential rewards are immense. We could gain a valuable outpost for scientific research, a strategic launch pad for future space missions, and a unique window into the history of our solar system. As we continue to push the boundaries of space exploration, it's crucial to think not just about reaching new destinations, but also about preserving the celestial wonders we encounter along the way. Who knows, maybe one day saving a moon won't sound so outlandish after all. Thank you for joining me on this cosmic adventure. If you enjoyed this exploration of Phobos and its uncertain future, be sure to hit that like button, subscribe to the channel for more mind-blowing space content, and let me know your thoughts in the comments below. Until next time, keep looking up.